Okay, solving problem number 6. Find the rate of change of total revenue, cost, and profit with respect to time. Assume R of X and C of X are in dollars. So, as we know, revenue, it's usually R of X, it's used for revenue. C of X is used for cost, total cost. And X is the amount of product, and dx and dt, the rate of change, how many more, with what rate of change they do the revenue. Okay, 7 units per day. So first question, find the rate of change of total revenue in dollar amount. Total 7 is unit per day, we need to know total. Okay, so revenue is 4x. One second, let me take off. Okay, so the revenue R of X is equal to X. Okay, so we need to find dr by dt, because as time goes, right, to get total. Dr by dt, it's going to be equal d 2x over dt. As I said, you can write down either the way I put it there or d of dt to 2x. Doesn't matter which way you put. Okay, now we are going to calculate dr by dt. So it's going to be dr by dt is going to be equal twice 2 and dx by dt, because we have t and we differentiate by t, and we have x, so we can't differentiate, so we leave it the way it is. Okay, but what do we know from here? That's the fact that dx by dt is 7 units per day. So which means dx by dt is, in our case, 7 units per day. So once I plug it here, instead of dx by dt, we are getting change of the rate of change of total revenue. It's going to be dr over dt is equal to times 7. Okay, and we are getting 14. So let's see if that's the first question we need to answer. 14, rate of change of total revenue. Yes, $14 per day. Why is it incorrect? Let's see one more time. What is wrong? Okay. Rx is equal 4x. Okay, I put 2x, right? Yeah, okay. 4x, never mind, we can fix it. Four x, here will be 4 dx dt, and here will be 4 times, this is 4x, and 4 times 7 is going to be 28. Never mind, we will go back and fix it. I'm pretty sure somebody noticed early So you expected that I will get wrong answer. Okay, there we go. Now we got it. Fantastic. Okay, what is second question? Rate of change of total cost. Okay, let's take care of total cost. So what do we have here? Our total cost is C of x. I took a picture of it, so I have it here. 0.01 x squared plus 0.2 x and plus 10. Okay, let's say now we take rate of change of total cost, so dc by dt, right? So it's going to be d by dt 0.01 x squared plus d by dt 0.2 x and plus d by dt of 10. Okay, so what is going to happen here? dc by dt, it's going to be equal, taking derivative of these two, it's going to be twice times 0.01 x, and we need to take derivative of x itself, dx by dt, plus 0.2, so, and the derivative of dx by dt, and the derivative of constant, it doesn't matter which the constant we have, it's gonna be 0. Okay, so from here we are getting, we know dx by dt is 7. Everywhere I'm going to plug 7. So dc by dt cost c 0.02 x and times 7, right? We can enter, might as well, x also. X is given 25. So might as well insert 25 also. Times 25 times 7. So we have, this is our 25 and this is our 7. Okay, so next is going to be plus 0.2 times 7. Okay, and we are getting how much? Let's do the math. dc by dt equal 0.02 times 25 times 7. It's 3.5, I believe. Let me double check. 0.02 times 25 times 7. Yes, 3.5. And plus here we have 1.4, 0.2 times 7, 1.4, and we are getting 4.9. So a rate of change, or the rate of change of total cost, 4.9. Oops. Okay, and we have to find out the rate of change of total profit. Okay, let's do rate of change of total profit. So we know that profit is equal revenue minus cost, correct? Total revenue minus total cost. And accordingly, rate of change of profit is equal rate of change of revenue and minus rate of change of cost. Okay, so how much is our rate of change for revenue? 28. Well, here it is. and minus 4.9. So 28 minus 4 is 24, and minus 0.9 is going to be 23.1. Okay. Well done. Moving to question number 7. So what do we have here? Suppose that price P in dollars and the number of cells X of a certain item are related by 4P plus 5X plus 2px equal 55. Okay, if p and x are both functions of time measured in days, find the rate at which x is changing when x is equal 3, p is equal 4, and rate of change of profit is 1.3. All right, well, let's start working. I'll take the picture of information so I can work with it. All right, let's get working. First question we need to find the rate at which x is changing. What is our x? It's number of cells, right? It's number of the cells. So what is where is our equation? And it is related to equation 4p plus 5x plus 2px is equal 55. So we are going to take derivative, okay, d by dt. So it's going to be d by dt 4p plus d by dt 5x plus d by dt 2px. Why we are taking by dt? Because it's a rate of change. It's related to time, right? In this case, it's times is going to be counted by days. Okay. And derivative of 55, it's a constant. It's going to be 0 anyway. All right? So let's see. Derivative of the 4p is going to be 4 and dp by dt, right? Derivative of 5x is going to be plus 5 and dx by dt, right? And derivative of the 2px, now this is it's a product, right? P times x. So we are going to use the following way. U v I showed before, I will show again. U prime v plus v prime u. So instead of prime, I'm going to use d by dt. Okay, so we're going to get plus, I can take, well, okay, I'll take 2 with it also. So it's going to be 2 d by dt 2p times x. Yes. Okay. And then plus derivative of x, d by dt x times 2p, right? Let's see. This is my u, this is my v. So I'm taking u prime, which is here, d by dt, and times v. And then I'm taking derivative of v and times u. Okay, and all this is equal 0. So what do we have here? Do we have anything in common that we can... Okay, let me do this one first. Let me open this derivative. It's gonna be 4 dp by dt plus 5 dx by dt. Now here we have x. This x has nothing to do with 2p. Let me take it like that. So 2 will come out, and x has nothing to do with derivative, so 2x will be out, and under derivative will be 2p by dt plus. Now here 2p will come out, and under derivative we will have dx by dt. So we ended up 1, 2, 3, 4 with 4 terms here. Do we have anything we can combine? Not like terms, but what do we have that we can substitute? dp by dt. At the beginning I took a picture, so here we have it's given. Okay, I didn't make up this. So dp by dt is equal 1.3, and then x is equal 3, x is equal 3, and p is equal 4. So from here we have 4 times, so dp by dt, it's gonna be 1.3. Yes. Next, plus 5 times dx by dt, and then plus 2 times p. No, hold on. 5 times dx by dt, 2 times x. Where is my x? Is 3. And dp by dt, and then plus 2 times p, be 2 times 4, and dx by dt. Okay, so equals 0, all this. dp by dt, I can also replace 1.3, see? dp by dt, and we have dp by dt. Let me clean this and put times 1.3. Very good. So we ended up only with dx by dt. So let's do the math portion of it and see what we are going to get here. 4 times 1.3, so 13 times 4, it's for 5.2, so with decimal notation. (5.2). Next, it's going to be plus 5 dx by dt. These 2, it looks like index. Let me bring down. Plus 5 dx by dt plus 2 times 3 is 6. 6 times 1.3 is equal 7.8. And 2 times 4 is 8 dx by dt. Okay, so 7.8 plus, like term, 7.8 plus 5.2, it's going to be precisely 13. let me this 13 move on this side. It's going to be negative 13. And here what we have left, common factor dx dt. And I'm getting dx by dt. Okay, it's going to be 13 dx by dt. 5 and 8. Okay. I was going to take common factor, but then I'm looking, there is no other term. So that means they are like terms. I can put together 5 plus 8. And from here, dx by dt is going to be equal negative 1. So therefore, the cells are decreasing by about 1 cells per day. Let's plug the number. Okay. Is changing by negative 1. Okay, I thought if they would be written decreasing, I would put just 1, but because it doesn't say anything, it says, then I put negative 1. It's going to be, I thought it's going to be cells per day. Yeah. Well, it's wrong. It should be cells per day. They messed up. Days per cell. Is there anything else? Okay, wait, maybe. Ah, yeah, here it is, cells per day. Okay. And I'm thinking, what's happening? Okay. So we are moving to next question, which is going to be 8. All right, let's see what we have here. The flow of blood in the blood vessels is faster. 1 second, please. Let me fix here something. Yeah. The flow of blood in a blood vessel is faster towards the center of the vessel and slower toward outside. The speed of blood V in millimeters per second is given by the following formula, where R, V is equal, where R is the radius of the blood vessel. Lowercase r is the distance of blood from the center of the vessel, and PL and lowercase v are physical constants related to pressure, length, and viscosity of the blood vessel. Wow, this is very interesting case, looks like going to be. Okay. Physical constants related to pressure, length, and viscosity of the blood vessels, respectively. Assume that R is a constant as well as P, L, and V. Complete parts A and B below. Okay, well, let me take the picture of it. Picture of formula, because I am not in medical area, so I need that formula we are going to work with. Okay, so, and I'll take the picture of the problem. There are no data. Okay, so it's asking find the rate of change dV by dt in terms of R and dr by dt when L is equal, here it is data. L is equal 80, P is equal 450, and so forth. Let me take the picture. Okay, let's start working now. So, the formula we are going to work with is going to be V is equal P over 4 L lowercase v r squared minus lowercase r squared. Okay, so what we are going to do, we are going to plug the numbers and given numbers and use implicit differentiation. So our P, which is gonna be pressure, let me see how much is our P. I don't see here. Let me go back and look it up. Did I take the picture of P? Yes. So here it is. 450. Four times. How much is my L? 80. How much is my lowercase v? Is 0.003. Let me write down all this here so you will be aware. So L is equal 80 millimeters. P is equal 450 and V is equal 0.003. Okay, so in the times here we have uppercase r squared minus lowercase r squared. So from here, what we are going to do, we are going to take derivative because we need to find rate of change for v. So we need to find dv by dt, question mark. All right, so let's distribute by r squared and lowercase r squared. First of all, how much is going to be, let's do the math. So 4 times 80 is 320 and times 0.003. So 3 zeros here and 1 zero there. It's going to be 0.96. One more time. Let me check. 4 times, silly mistakes are always there. 0.003. One more time. What's happening? I think I missed there some 0 times 18 and times 0.003. I don't like relying on calculator. If I would do myself, I would be done already. Okay. So 0.96 and here I have 450. So if I distribute this on this parenthesis, it's going to be r squared and minus 450 over 0.96 lower r squared. All right, so let's now take derivative. dv by dt is equal. So 400 d by dt, 450 over 0.96 r squared, and minus d by dt, 450 over 0.96 p squared. Okay, so therefore, what do we get here? We are getting dv by dt is equal 450 over 0.96, and r squared derivative, it's going to be 2r, right? And then r, it's going to be derivative of r, and minus 0, because r accepted as a constant. Let's go back. Let me show you here. The very last sentence in the word problem, assume that r is a constant as well as p, l, and v. Because it's a constant, so entire the derivative becoming 0. So from here we are getting how much was our dr dt. So our uppercase radius is going to be, oh, it's not given, so we're going to leave it like that. So dv by dt is equal twice 450, it's going to be 945 times 2 over 96 r, and then dr by dt, and this is going to be our answer. So let's see. It's gonna be, I would say, it's gonna be first one, because r is a constant, lowercase r is a constant, so it's gonna be this one. It's gonna be 900. I'll put here uppercase r over, where is my over? Here it is, 0.96, yeah? How much was it? 0.96, yes. Okay. 0.96. Okay, very good. So moving to question number B. What do we have here? When shoveling snow in cold air, a person with history of heart trouble can develop angina, chest pain, due to contracting blood vessels. To counteract this, he or she may take nitroglycerin tablet, which dilates blood, or dilates, I don't know how to pronounce, blood vessels. Suppose that after nitroglycerin tablet is taken, a blood vessel dilates a rate of dr by dt 0. Let me write down this information. 0.000 zeros dr by dt 0.00016. Okay, millimeter per second at a place in the blood vessel where the radius is 0.084. I guess it will be better if I take the picture of this. Okay, so and we need to find dV. So let's read one more time. When shoveling snow in cold air, a person with history of heart trouble can develop angina, chest pain due to contracting blood vessels. To counteract this, he or she may take a nitroglycerin tablet, which dilates blood vessels. Okay, suppose that after nitroglycerin tablet is taken, a blood vessel dilate at rate of dr equals 0.00016. Okay, millimeter per second at a place in the blood vessels where the radius is 0.084 millimeter. Find the rate of change dV by dt. Okay, Let's start working on it. So we need to find dv by dt. All right, so what do we have? So we have dv by dt, here it is. Okay, so in this case it's giving us a radius 0 point, here write down, radius is equal 0.084, right? And dr by dt is equal 0.00016. So all we have to do is plug the numbers. So dv by dt, because we got this general formula, now it's asking specific case. If at the rate of dr by dt, rate of change of radius is 0.00016, and radius is 0.084. So we are going to plug in and find rate of change of v. Okay, so this is equal 900 over 0.96 times 0.084 and times 0.00016. What a nasty calculation. Okay, well, I guess we will do it easy way. This is what I will do. I will increase 0.96 to 96 by 2 positions here, and here I will cut by 2 positions. Okay, maybe I will confuse you even more. Let me just go do the math. Easy way. Okay. Here I have to use calculator because it will be impossible. So 900 times 0.084 is gonna be 75.6, and we need to divide 0.96 and times 0.00016. So 75.6 divided by 0.96, we are getting 78.75, and times 0.00016. Okay, by dt, dv by dt. So, and then we times 0.00016, and we are getting 0.0126. Okay, and that is going to be millimeter per second squared. Okay, so let me place the answer. Zero point 0.0126. Okay, and here is going to be millimeter per second square. Okay, we made it. Now moving to question number 9. I guess I will take a picture of it right away, and maybe the whole problem also. All right, so what do we have here? A ladder 26 feet long leans against the vertical wall. Okay, it's we see that. Let me here it is, 26 feet. Okay, if the lower end is being moved away from the wall, okay, at the rate of 2 feet per second, okay, L, if the lower end is being moved away, so dl by dt, rate of 2 feet per second. Let me write down. L is pushing away distance. Because it's a rate, we take dl by dt, 2 feet per second. Okay. How fast is the height of the top changing? And this will be negative rate because it's going down, okay? When the lower end is 10 feet away from wall. Okay, when the lower end is, okay, so I guess this one is the one that they lower, but they lowered it to this position. Original was this one, 26. Okay. Oh, I'm not drawing properly. Of course. Let me just draw from the beginning. So here we have 26, and as you are moving down, getting here, 26 feet. Okay. So we need to find practically negative rate when the lower end feet moves 10 feet away from the wall. Let me read one more time. How fast is the height of the top changing? This will be a negative rate when the low end is 10 feet away from wall. Okay, it marked down as x, y, okay. This is x, this is y. And I'm assuming this x is 10 feet away. It says 10 feet away from the wall. Okay. So, since we need to find out how fast is the height of the top is changing, which is y, that's mean if how fast is changing, meaning we need to know dy by dt, right? This is what we need to know. Okay. So, in this case, let's see, we can see here, we can use Pythagorean theorem, which means x squared plus y squared is equal 26 squared, right? So from here, 26 squared is 676, x squared plus y squared. Now we need to find the rate of change of height, right? Which means we are going to take implicit derivative. We have two variables. So that's going to be d by dt x squared plus d by dt y squared. And this is equal, already I put 0 because derivative of 676, it's going to be 0. Constant, it's going to be 0, obviously. Yes? So from here, let's take derivative. So derivative of x squared is going to be 2x, and derivative of x, dx by dt, plus derivative of y squared is going to be 2y, and derivative of y by dy by dt, and that is equal 0. So from here, what we're gonna do, we need to find dy by dt, because this is our question, right? So dy by dt, all we're gonna do, divide by 2y, both sides, right? And that is going to be equal 2x, first of all, okay, 2x by 2y, and then dx by dt, where 2 and 2 will cancel, plus 2y and 2y is gone, will be dy by dt equals 0. Well, and to find dy by dt, it's going to be equal negative x over y dx by dt. All right. So where are we going from here? We are going to plug the value. Our x was how much? 10 feet, right? So x is equal 10 feet. In the rate of change, okay, let me, instead of L, I will put this dx because it's moving away, right? With the, this is a rate of change from here. Where from is this constantly eraser comes on? So this is going to be pulling from this point to this point with the rate of change, dx by dt, 2 feet per second. Okay, dx by dt, it's gonna be 2 feet per second. Okay, well, let's plug the numbers and find the y, obviously. Let me see. dy by dt is equal negative x is 10. Here we have y, and dx by dt is 2. So we are missing here y, right? We need to find y. Okay, so how we can find the y? I'm going back to our Pythagorean theorem. X squared plus y squared equals 676, right? Or might as well just put 26 squared. It will be easier to work with. So y squared is equal 26 squared minus x squared, and y is equal square root 26 squared minus, how much is our x? 10 squared. So we are getting y is equal 26 squared was 676 minus 10 squared is 100. We are getting square root of 576. 576, I believe it was maybe 24. Let me see. I believe this whole number should come out. 24, yeah, bingo. Y is equal 24. And from here, dy by dt is equal negative 10 over 24 times 2. And we are getting how much? This is 1, this is 12. Okay, and then what else we can cancel here? 10 and 12 by 2. This is 5, this is 6. So our result is going to be dy by dt is equal negative 5/6. What does that mean? That the height of the top of the ladder is changing at a rate of negative because it's sliding down, right? Feet per second. All right? So 5/6, let me place the answer. Let's go back and double check what we have. The numbers, it can be some math problem there. Okay. Dx by dt is 2. Yes? Here, 2 feet. Let's double check. Here, dx by dt, here it is from the away from wall, 2 feet per second, okay? And when the lower end is 10 feet away from wall, that's x. Correct? Okay. So our x is going to be where is our problem that we need to plug? Okay, here it is. Let's double check this one, negative x to y. Okay, dx by dt. Okay, so x is 10, y we calculated 24, right? And dx by dt is 2. Yes? Okay, so let's see, 24, 2 and 24, let me do one more time this. 10 times 2 over 24, 1 and 12, okay, by 2, 5 and 6. Okay, so we got that far. Did I put negative sign? Hold on 1 second. Oh, there we go. Of course, I didn't put negative sign. Negative 5/6. Okay. Check. We got question number 10. And we have 10 and 11, and we will be done. All right, let's see what we have here. The volume of cantaloupe is approximately 4/3 of pi r cubed. Remember what it is, this volume formula for sphere, right? Okay, the radius is growing at the rate is a rate of 0.5 centimeter per week. That's a radius rate, dr by dt. Yes? Okay, 0.5. Let me write down. .5 centimeter per week. So this is how it's growing, positive 0.5. All right. At a time when radius is 6.8 centimeters. Okay, the radius is 6 centimeters. How fast is the volume changing at that moment when the radius is 6 centimeters? That's 6.8 centimeters. We need to know how fast the volume is changing at that moment. Okay, let's start working on it. So our volume is equal. So we need to find dr by dt, right? V is equal 4 over 3, it's like sphere, pi r cube. Let me put lowercase since I started with lowercase, because uppercase would mean some different r. Okay, so we also, let's put, we need to find the volume, how it's gonna change when radius is 6.8 centimeters. I apologize. Let me check one more time. .8, yes, and 0.5. Okay, very good. So dv by dt is equal question mark. Okay, well, we're going to differentiate equation with respect to t, because changing of volume, it's going to be in respect to time, correct? So it is going to be dv by dt is equal 4 over 3 pi. Now we're going to take derivative of r also, because radius is also changing, right? Increasing. Therefore, it's going to be d by dt r cubed. Yes? Okay. This is going to be equal but why I took out 4 over 3p? I could leave it with r cubed, but one way or another it should come out because it's a constant. So no difference if you put under d by dt or take out. So one way or another you have to take out, because it's not differentiable. 4 over 3 pi, it's a constant. So, and our dv by dt is equal 4 over 3 pi, and derivative of r cubed is going to be 3r and dr by dt. So we have r, we have dr by dt. We are going to plug, so dv by dt is going to be equal 4 over 3 pi. So for at the minute of 6.8, right? 3 times 6.8 and times dr by dt is, we have 0.5. Okay. So from here we are going to get dv by dt is equal, well, pi is 3.14, that constant we are going to use. And I'm multiplying everything by each other. So with the difference, this 3, I'm canceling with this 3. And I'm going to have, let's go, do all this multiplication. So 4 times 3.14 times 6.8 times 0.5, and we get 42.704. Let this multiplication put as a cross, because I'm afraid some students will get confused which one is decimal, which one is multiplication. So I'll just put like this to multiply. Okay, 42.704. Let me double check. It's coming out, I think, way too slow. 4 times 3.14 times 6.8 and times 0.5. Well, yeah, we are getting 42.704. 0.5. Let's try, okay. How much? Decimal. Okay. 1 decimal. So it's gonna be 42.7. Oh no. 42.7, and it's gonna be, because it's a volume, the changing centimeter cubed per week. See, I felt that something is wrong. Let's go back and check the math. There is nothing else left. Double check the data. We have 0.5 and 6.8. All is good. All right, let's see what we did wrong and where. Okay. dv, okay, 4 over 3, I'm checking this one. This is 3r, dr by dt, 4 pi, okay, 4 pi, oh, I found it. Derivative of r cubed, it's going to be 3r squared. There we go. Here, dr by dt. R cubed, remember? Derivative is going to be 3r squared. And then we take derivative dr itself also. Okay. So, since we have r squared, and that means we need to multiply by 6.8 one more time, which means here I'm multiplying 42,704 by one more time by 6.8. Let me put this type of multiplication. Okay, times 6.8, and I'm getting 290. Now this is better. I was feeling with given data it's kind of too slow. 290.4. Okay. This looks more like a correct answer. 290. Where is my 0.4? Okay. I round it till 4 decimals. What? Okay, that's it. I'm opening final check. I want to see what it is because I'm sure we solved it correct. God, 290.5. How they got now 0.5? I did math, I got to 290.4. Anyway, my answer is correct. So you can do the math on your own and be sure. Because the full answer is 209. I know what it is. Okay, they put 3.14 evidently. Hold on. This 3.14, they put the whole 9 yard maybe. That's what it is. Okay, instead of 3.14, there is 6 digits. They put the entire 6 digits. That's why it rounded till 5 instead of 4. Okay, at least we know we solved it correct. So when you place the number, you make sure you put all 6 digits. You can Google it, value of pi. So, okay, so we consider this is solved. And I'm looking at question 11. Looks like it's an identical question as we solved already. Volume of cantaloupe. Therefore, I'll just take off question 11. So altogether, you will have 10 questions in this homework. That's plenty because it's a long calculation. So that's enough. Okie dokie. See you at next recording. Bye.